This is Mr. Beck Does Your Homework. This is AP Physics Homework 2.7, question number 9. It says a ball is thrown from the top of a building upward at an angle of 35 degrees to the horizontal and with an initial speed of 18 meters per second. The ball is thrown at a height of 33 meters above the ground and hits the ground 56.831 meters from the base of the building. What is the speed of the ball just before it strikes the ground? The acceleration due to gravity is 9.8 meters per second squared. What it's looking for is the speed of the ball. When it gets here, it's going to have some y velocity, it's going to have some x velocity, and then we can combine those two to get this, which is going to be the combined velocity, or the speed of the ball is going to be that amount. It'll have a certain angle too, which I'm not asking you to solve here, but I'm looking for my final velocity. So I'm going to need my final velocity in the x world, and I'm going to need my final velocity in the y world in order to get this by Pythagorizing those together. So let's see what I got. I've got x world, I've got y world. In the x world, I have an acceleration of 0. In the x world, I know that my displacement is going to be 56.831 meters because it's going all this way in the x world. I don't know my time, but I do know my initial velocity and my final velocity and my only velocity and all my velocity in the x world, because I've got this, which I turn into a triangle here. And so I want my velocity in the x world and my velocity in the y world. My velocity in the x world, since it's adjacent to the 35 degrees, it's going to be that velocity of 18 meters per second times the cosine of theta. So that's going to be 18 cosine 35. In the y world, my acceleration is negative 9.8. My initial velocity is going to be this one up, which is going to be the sine of the angle, because that's opposite the 35 degree angle, opposite theta. So it's going to be my velocity of 18 times the sine of theta. So it's going to be 18 times the sine of 35. That's my initial velocity. I'm looking for my final velocity. And the other thing I don't know the time from over here, and I don't know my, I do know my displacement is 33 meters down. It's going to wind up negative 33 meters by the time it hits the ground. So with acceleration, displacement, initial velocity, can I get final velocity? Sure I can. I can get my v squared equals my v0 squared plus twice my acceleration times my displacement. So my final velocity squared is my initial velocity squared, which is this 18 sine 35. I'm not going to write it. I'll just write v0 squared again, plus twice my negative 9.8 times my negative 33 for me. So this is going to be a negative chunk. So I've got v squared is v0 squared plus that. So then I'll get my v is my square root of all of this. So this is positive. This is going to be negative, negative, also positive. So whatever this number is, this is going to be even more than that. So this should be a really big number that I'm square rooting. Now I've got that, and that is my final y velocity. So that's my downward component. This 18 cosine 35 is my final x component, because it's my beginning and ending, my total x velocity. So with my x velocity and my final velocity in the y world, I know these are going to combine to make a vector this direction. So I'm going to slide this over to vector add them. And this is my vy, this is my vx. So now I know that Pythagoras tells me that a squared plus b squared equals c squared. So this one squared plus this one squared, square rooted, and I'm getting my c squared. By the way, if you just left this as v squared, that might have been a quick little sneaky trick to get that without square rooting it and then square rooting it again. But that is my speed of the ball will be the magnitude of this vector. So that'll be my square root of c squared.